Alright guys, so it's whatever you want to talk about. Anything you haven't turned in yet. Any homework, any corrections. It would be the same if you turn it in today as if you turn it on the day of the final. So you can turn it in either of those days. And it won't be any more late than it currently is. Right? So if you didn't turn in chapter 1 homework yet, it is remarkably late. But if you turn it in, you'll get more than the 0 that's currently sitting in the spreadsheet. Cool. And if there's corrections, as long as you got enough of them right, you could still get some back, just less than you could have before, if it's late. Cool. Okay. And please realize that the final exam starts, is this correct? I guess it is. 9:25 on Thursday, the 26th. Is everybody with me? Mm-hmm. Everybody here right now is going to show up on time for that final. If anybody's not here, they show up late, then I'm going to say you have chosen to not use all the time. I'm not staying later for them. So you all show up on time. Yay. And you'll be fine. Don't show up at the normal class time because that'll suck. You'll have an hour for the final. You don't want that. You want more. All right, cool. So yes, last time we talked about the formula sheet. I think we did a couple examples of something. What do you guys want to focus on today? Anything specific you guys have in mind that you need to look at? It's basically totally up to you what we do today.
Maybe go over just some of the problems from the final exam, maybe? Yeah.
Yeah.
Practice,
All right, cool. Can we make that a little more specific?
Start at 1. And
I can just give you the answer key then. I mean, I've already done these problems. Let me see. All right, let me just go ahead and give you guys the answer key then. How do I want to work this? I wish I would have realized that. Yeah, that's right. It basically matches up to there. All right. How many do I have here? We've got 12 that are perfect. I'm just going to give out these. I'll tell you what, if somebody, at least one of you will remind me, I'll scan the couple pages that are different and post them, email them out. Somebody will remind me about that.
No, I did not. Did you?
So the whole first page is almost the same. I think number 4 and number 5 just switched. See number 4 in the answer key? Isn't that your number 5?
Yeah.
And number 5 is your number 4? On the next page?
Mm-hmm.
All right. Then I decided to, at some point in history, I think number 6 is the same. Number 7 is the same. 8's the same, and then 9, 10, and 11 are different. Right, so the last 3 are definitely, they're the same kind of problem. Just some point in history I changed the numbers, and I added number 11 sometime, and I just didn't separate the keys. So does everybody understand what's happening? So I'm going to scan those answers from the correct key and then send them out over email. I like it. Okay. Sure, yeah. Oh, yeah. I couldn't remember where they ended up. Yes?
Can I remind you just in case it's
Say again?
remind you, like, to send the email or remind you?
Are you? All right, I'm not sure how to take this because that sounds like a. Can you? Of course you can. I thought you were doing it right now. Like, oh yeah, John. That sounds like something I would do. A real smart ass. Oh yeah, I'm reminding you. But of course you can. Please, yes. More than one person reminding me is never a bad thing.
As far as the definitions that were in chapter 1,
Yeah, those are not. No.
Oh,
Yeah. Don't worry about us. We made it through them. They exist. That's good. You could have a. I could put like a histogram problem, not one that you have to create, but one that's made and you just have to tell me stuff about it. Because part of our SLOs is just being able to interpret presentations of data. Yeah. You know, and if you want to go over any of those that are different on this answer key, we can do that.
Can we do that?
Yeah, there you go. Let's see. So number 9. Yeah, so just reading through number 9. Obviously in the question it says test the claim. So what kind of problem is this? Hypothesis test, right? And more specifically, am I going to use the big Z-star formula or the small one? How many samples? I know it's like, I don't know what you meant, Jeff. There's a 50-50 shot on that. I learned it from you. The big one, yeah. How many samples are there? There's 2 samples. Number 9, if you want to play along for right now. Number 9 has 2 samples, so I need that big-ass Z-star formula that's got room for X bar 1, X bar 2. So let's take a look. So part A is the older one. Part B is the... What distribution am I going to use on part B? What am I testing in part B? Who's playing with me? Anybody playing along with me?
Claim that
I'm testing a standard deviation, so what distribution do I have to use? What creates the normal distribution? What creates that? What tells me how skinny or how fat it is? What tells me that? What tells me how fat it is? If it's really fat versus really skinny, what's the difference between the two? The what? Standard deviation, the spread, right? So the standard deviation creates the normal distribution. If I'm testing what the hell the standard deviation is, can I use a normal distribution? No. What do I use then?
Chi-square.
Chi-square. So when I'm making a test about a standard deviation, and why does that make sense? Here I got Z-star, it's got X bar 1 and X bar 2 in it, blah, blah, blah. What's the chi-square formula? There's 2 of them. There's the one where they observed minus expected, like number 11. Could use. With standard deviations in it, right? So I can make a Z-star using sample means, but I can make a chi-square using sample standard deviations. So you have a couple things trying to tell you what to use on 9b. I can't test a claim about a standard deviation using a distribution that has to know the standard deviation. Oh shit. Right, so that's one reason why chi-square exists. Because then I can use this bad boy here. Become an S. Okay. All right, so 9A is a nice thing. It's about, there's two means, but that's still, it's old news. It's a test about means, so I can use normal distribution. That's what that's all about. So what is the claim on 9A? Yeah, so the claim, mu1 equals mu2. Who are the ones? Yeah, men, that's right. So, women. Okay, cool. I like it. So now, which one is that? Yeah, I think I heard you, the hoe. I like it. So the I is? Yeah, why is it the hoe? Because it's got equal sign in it. I like it. So how many tail tests will this be? 2 tail tests. I love it. The first day we did this, you never thought you'd get to a point where you kind of know how these work. All right, so this is definitely 2 tail test. I like it. What's the next step? I didn't give you any of the steps here because I want to be evil in the practice test. The actual test, I'll tell you the steps. All right, but I figured you had enough handouts to go off of, for sure, for me. So what's the next step? Good, Z or T? Yeah, why T? 2 things.
Standard deviation, something else.
There's no.
The sample deviation.
I like it. I like it. So you don't know the population standard deviation, you only know the sample standard deviations. And?
You don't know.
And it's normal.
Why is it normal?
Because it's greater than 30.
Yeah, N1 and N2 bigger than 30. Check. So a big takeaway from this class, I think, from the semester is if you know that you have something that's normally distributed, the world is great. Right? So we're always desperately trying to get there. If not, there are other things we can do. We just don't learn about them in Stats 1. Let's see. Let me take you away. Take me away. So the third step, now that I know what I'm allowed to use to talk about this, I go ahead and use it, and I set up the rejection region. I like it. So you know we're using t-scores. Alpha here was, where'd you go? 0.01? Degrees of freedom, what am I going to use for that? 33, right? The smaller one? 33. 2-tail test. So who can look that up? What's those t-scores going to be for that? I don't know if I have a t-chart anywhere. One more time, I'm sorry, 2.733? 2.733. You guys agree? Everybody concurs? All right. So then how do I say this in words? It's less than that. Or bigger than that. We can do what? Reject the hoe. Support the high. I was about to say, I think that's Bernie Sanders' platform, but no, I didn't want to say. I chose not to. So what about, so that sets up what far enough away is going to be. All right, sorry. Now I see how far away I got. It's a part of this platform. So now I can do Z star, and if you have your formula sheet sitting there, which one am I going to use? I think I already said it. The one that's got.
Just have a question. Don't you do both for the male and female? Like exactly what you just did right there?
No, definitely not. Because it's a claim, it's a test about comparing the two against each other.
Okay.
So I need a single I need to see how, so if we can write this down, I can answer your question better. What's z-squared I'm going to use? What formula?
mu1 minus mu2.
See, I want to see how far apart they are from each other, right? So I need a single distribution that represents how far apart they are from each other. I don't want two separate ones. I want to put them together, see how far apart they are. So if I got close to here, that means the difference between them is not big enough. And this will be over this big old thing, right? S1 squared over N1. The most common mistake people make is to forget to square those. Cool. So I know data entry is a beautiful part of statistics. Correctly putting things into a formula is another great place to make mistakes. So this is where in the calculator you want to do this. You want to make sure you don't leave the square root too early. What was x bar 1? 300.4. And then for the
296.6 for x bar 2.
let's see where we at. 11.56, 17.31. Okay. 1.56, where we're at. Oh, why did I do that? It's so evil. Oh, okay, I'm okay. 34 and 38. I am evil, but not for quiet. It's pretty cool. I mean, we talked about where this formula came from. I talked about where this piece came from. We talked about why it kind of makes sense. But after you do all that, it really is just pick the right formula and put things in the right place. I mean, it really is. It should be. You did a lot of work to make this thing. You shouldn't have to redo that work every time you do a problem. But it also removes us from why what we're doing makes sense. And it becomes, math is just a bunch of plotting numbers and getting numbers out. But it's based on a lot of work as to where to put the numbers and what to do with them, right? I don't know how to articulate this correctly. This is something as a student, it's hard for you to realize you're losing connection with the idea of something. You're getting way too wrapped up in the numbers, which everybody thinks math is, and that ain't what math is, right? Anybody do that yet? Maybe I should.
1.105.
1.105?
Yeah.
So 1.11? Or was it 1.104 or something?
1.11.
So that's good.
I like it. Cool. I like it. So did we make it? And I called the Z star. Nobody freaked out, right? Hopefully we're all at that point. It don't matter if I call it that or that. It's the same formula. So did we make it far enough away?
No.
Yeah, right here. Woohoo! Somewhere in there. So we didn't make it anywhere near far enough away. I like it. So the difference between these two samples was not large enough to be able to say it doesn't look like they're equal. The populations, I like it. So we have failed. Failed to reject the hoe. Failed to support the high. So which one was our claim? I still have people not sure how to do this. The claim is this one, so then you use this language to discuss it. There's nothing more than that. There's nothing more than that. That's all it is. Do you say reject or support? You just throw it in, you go, it's got a 50-50 chance. No. Which one was the claim? That's it. That's all. You use that language. So we have not found sufficient evidence.
To reject claim.
Good. Sufficient evidence to reject the claim that
Mean scores are equal or the same for males and females.
good mean scores same for men and women. What was it? I can't remember this symbol. Same for men and women. Blah blah blah. That is English. You have to take my word on it. But you know, so again, I just want to remind you, the whole chi-squared thing might be really weird, but when we did a test, it felt like this, right? We'll do the next part. We'll do part B now, but and that'll be the chi-squared one. That's the more recent stuff. So any questions on this kind of thing here? Okay, so let's try part B. Did I do part B in there? No. Maybe I added that in. Okay. So has everybody got this here?
Yeah.
Oh, okay. Let's look at part B. It says, test the claim that the standard deviation for all men, so now I'm just looking at the men for part B, is less than 13. Now the standard deviation for the sample of men was what? 11.56. So again, I know I've made this point before. That is less than 13, but it's just a sample, so it's got to be enough less than 13 to make it seem that the population would be less than 13. So if you're trying to prove something using a sample, the criteria for proving something has to be kind of difficult, stringent, because you only have a sample, you don't have everybody. All right, was that stalled enough? Okay. So 9b, it's got basically the same steps. I'm not going to be as stringent with chi-square stuff. What is the claim that's being made?
The standard deviation for all males is less than 13.
I like it.
Alpha.
Who to what?
Alpha is less.
No, and then alpha.
No.
Sigma. Yeah. So the claim is the population standard deviation for men is less than 13. So which one's that? The high. I like it. Cool. Just make sure you use the right symbol also. You talk about percentages, use p's. You talk about me's, use mu's. Standard deviation, use sigma. I like it. I hate taking points off that. Such a little thing. So how many tail tests will this be? One. Where?
Left to left.
Yeah, I like it. So one tail test. We pretty much skipped the whole concern about if we're allowed to do anything. We just do it at this level. Where am I at? So alpha is 0.05. I got a one-tail test down there. And the beautiful thing about the one nice thing with the chi-square chart is it's broken up. You look where you want the tail. So if I want the tail down there, I'm going to look on this part of the chart. Did I bring one with me? Jeff, you couldn't even bring the entire correct key, but hey, look at that part. I'm so mean to myself. What's the degrees of freedom? 33?
Yes.
Cool. Panasonic. Sorry, that's all I can think when I say that. Okay. No supersonic, right? Okay. So if I have, so where am I going to look? I know I'm going to look on this side because the tail is on that side. And this chart is set up to only understand areas to the right. So what area is to the left of it? 0.05. So what area is to the right of it? .95. So that's what I'm going to look up. So I really want you to realize that the chart helps you remember, oh yeah, I got to adjust it because I want to look on that side to get a tail on that side. That's kind of nice. But I can't look at 0.05. It's on the wrong side. Oh shit, 0.95 degrees of freedom is off the chart, Jeff. So of course here I don't go to 33, so what am I going to use?
30.
Yeah, this is kind of a bad one, but oh well, too bad for you, Jeff. Because look at that disparity there. Oh well. We'll use 18.493 for now. I'll give you one that's actually on the chart, on the test. 18.493. I mean, when in doubt, you make the test harder to pass, and that would be harder to pass to get something less than 18. Not a kidney stone or something. I don't know. I don't know if that's where your brain went.
What?
So this sets up how far away something is, hard to pass. How far away I have to be, and then the next step, of course, is how far did we make it? What formula do we use for the next step? I mean, normally I would find Z star now. But this is a chi-square, right? You can draw it, right? But it's too bad for me.
So the chi-square.
Yeah, chi-square. Yeah, I'm talking about standard deviation, so it'll be that n minus 1. I like it. And we know what all these things are. What is sigma? 13, yes. And S is the standard deviation we got from our sample, which was what?
11.56.
That was for the dudes, right?
Yeah.
Okay, and then whatever that comes out to be there. Yes?
Why is sigma 13?
Because it is. So remember, in the hypothesis tests, it's our sample mean minus the mu. What's the mu? We assume it to be what's in the claim. We're saying, okay, assuming that is right, assuming it is 13, okay, so we're assuming it's 13. We want to show contradiction. We're trying to contradict it by saying, assuming it's 13, look how far away I got. Nah. That's the less technical way to summarize a hypothesis test. Did anybody do that yet?
26.094.
26.094? I like it. So did we make it... Oh, I didn't say this in words, and that would probably help us out a little bit. How do you say this in words if chi-square is? Less than 18.493. So now, that would mean we could reject the null, support the high. And again, a lot of misunderstanding about this is it's not exactly the same as z-scores because chi-square scores can't be negative. And that throws us off a little bit. And then the numbers get big because it's all on one side of the picture. So that's why it's a little weirder. But it's the same idea. Did we make it in there? No. We're at 26. Shit. Right? So what does that mean? We fail to reject the low, fail to support the high. And like Dean said, the claim was the high, so that's the language we're going to use. Yes, sir?
How did you get to 48.493?
No, I'm sorry. Step number 1, write like me. And then it's amazing what you get. You get all kinds of, you get Swahili paint maybe up here. I don't know. So how do I say this then? We have not found sufficient evidence to support the claim that the standard deviation for all men is less than 13. That's the claim. Just put in what the claim is. You go right back to the paragraph from the problem and put exactly my language in. Like, don't just say ho or hi. Say what it is. Say what the claim is. Like it. This is evidence, by the way, right now. Evil. There's plenty of evil to find in math. So that's two different kinds of hypothesis tests, but they both feel the same. And if I did a hypothesis test about a percentage, we would use a different z-score formula, the p hat minus p1, right? So really, this is just kind of like another level of that. You have to use a different formula to find how far away we are. But this step still has to use something to figure out how far you are away from something else, right? Okay. Good. All right, good.
I may be just having a brain fart, but is there supposed to be a check that we're to do to whether or not we use chi-square?
Well, the underlying distribution itself has to be normal, but so many problems the book is really bad about mentioning.